In this lesson, we'll review linear functions, specifically the three forms of a line, the slope or rate of change, and the y-intercept or initial value. And we'll start with a contextual problem. Mark the carpenter started his day with 10 sheets of plywood. Every hour he used 2 sheets of plywood. Complete the table, make a graph, and write the equivalent forms of a linear function that represent this situation. So with our table of values, if x represents the number of hours Mark has worked that day, and y represents the number of sheets of plywood he has left, after 0 hours, he has 10 sheets of plywood. That's his initial starting point, right? He uses 2 sheets of plywood each hour, so after 1 hour, he has 8 sheets left. After 2 hours, he has 6 sheets left. You can see that this is a decreasing linear function. Every hour, he's dropping 2 sheets of plywood. He's losing 2 sheets. So the rate of change is -2. And it's a linear function because the rate of change is constant. Now we can take these values that are in the table, we can consider them as ordered pairs, and we can graph each ordered pair as a point on the coordinate plane, starting with 0, 10. That's our y-intercept, or our initial value. 1, 8, 2, 6. You can see that these points are going to lie in a straight line. And again, a characteristic of a linear function. Let's think about the domain of this function. What are the allowable x values? Well, in this context, x is the number of hours Mark has worked. It doesn't make sense for Mark to work negative hours, so the domain is x is greater than or equal to 0. The range are the allowable y values. In this context, y are the number of sheets of plywood. The most he has is 10. The fewest he's going to have is 0. So 0 is less than or equal to y is less than or equal to 10. We can think of this as y is between 0 and 10. Now let's go on to our equations. The slope-intercept form is the most familiar, y equals mx plus b, where m is your slope and b is your y-intercept. So y equals -2x plus 10, because -2 is the rate of change and 10 is the initial value. Standard form of the line. We have to have x and y on one side of the equal sign and the constant term on the other. Let's add 2x to both sides of the equation, and we get 2x plus y equals 10. Now the point-slope form of the line, we can use any point that satisfies this function, any point that is on the graph or in the table. I'll use this point, 2, 6. And the point-slope form of the line is y minus this y value of 6 equals the slope of -2 times x minus that x coordinate of 2. And we'll get more practice with that later on. Here we have slope-intercept form that we'll be reviewing. We're giving you an equation in slope-intercept form, and we want you to graph the line. So what is your starting point? What is your initial value with y equals -2x plus 1? 1 is your initial value, always on the y-axis. Your slope is -2. Let's write it as a fraction, -2 over 1. Let's use this fraction and think about rise over run. Let's drop down 2 from my initial starting point and to the right 1 and continue that pattern. Connecting those points, there is my graph of the line y equals -2x plus 1. In the next example, the graph is there. We need to come up with the equation. So we start with our y-intercept. We look for a lattice point. We think about our equation, y equals mx plus b. We have our b, right? We know our y-intercept is -1, but my slope is the rise over run. So let's start at that bottom point. Rise is 2, run is 3. My slope is going to be positive 2/3. Equation y equals 2/3 x minus 1. Now we'll move on to standard form. Definitely not as familiar as slope-intercept. Standard form of the line is ax plus by equals c. So the equation has been given, and to graph this line, it's a good idea to use intercepts. We take a table of values, we substitute 0 for x to find our y-intercept. I can put 0 in place of x in my equation. My equation becomes 3y equals -12. And I just think 3 times what number is -12? That would be -4. Now I want to find my x-intercept. Let's set y equal to 0. My equation becomes -2x equals -12. And I think -2 times what number is -12? That would be 6. Now I graph these two intercepts, 0, -4, and 6, 0, and I connect, and there's my line. In the next example, I have the graph of a line, and I'm asked to write the equation in standard form. So I start off by observing there's a clear y-intercept here of 2, and I can measure the slope. The rise over the run is -2/3. I could start off by writing the equation of this line in slope-intercept form, but a fraction is not a good idea in standard form. So to eliminate the fraction, I can multiply all terms in the equation by that denominator of 3. So I get 3y equals -2x plus 6. And now add 2x to both sides of the equation to turn this equation into standard form. 2x plus 3y equals 6. And finally, point-slope form of the line. An equation has been given in point-slope form, which looks like this. Y minus y1 equals m times x minus x1. So we need to look at the equation that's given and interpret what is my slope. My slope is -2. And what is that point that this line passes through? The point will have coordinates x1, y1. So I look at my given equation, I identify my x1 and my y1. This line will pass through the point with coordinates 1, 3. I graph that point. This becomes my starting point. And then I use my slope of -2 to graph the other points that lie on this line, and I connect. And there is the graph of the line whose equation was given in point-slope form. Finally, I have a graph of a line, and the y-intercept is not clear. It is not a lattice point. The y-intercept is some fractional value. So when this is the case, we don't like to start with the slope-intercept form. Instead, we start with the point-slope form of the line. We look for the point that the line passes through. We find the coordinates, -2, 1. Those two numbers will be substituted into the point-slope form, but I also need the slope. So I find another lattice point that lies on the line, and I look for the slope. This line is decreasing. The slope is down 1 to the right 3, -1/3. I now have everything that I need to substitute into my original equation. So I write y minus the y value of 1 equals -1/3 times x minus -2. And then I can rewrite that as parentheses x plus 2.